Hi, my name's Eleanor Dearlove. I'm an IPM consultant at ADAS in the UK, and I'm going to be demonstrating today how to use the IPM Decisions Platform. The IPM Decisions project is funded under the European Commission's Horizon 2020 programme, and the main objective is the development of the online platform hosting decision support systems related to the integrated management of crop pests. Here I'm going to demonstrate the platform in action, which is now live and accessible to all. But before we jump in, just to clarify, where I'm referring to pests, I'm talking about any weeds, pathogens or invertebrates that may cause injury to crops. Decision support systems can cover anything from forecasts to thresholds, but ultimately indicate the risk associated with crop-pest interactions at any given point in the season. The platform is an online marketplace for accessing IPM decision support systems, which will also be referred to as DSS or DSSs, and associated models, resources such as weather data. The platform consists of 4 dashboards targeting different aspects of decision support systems. The first 2 are the Use and Compare DSS dashboards. The Use DSS dashboard is the main area for seeing current pest risks. Then we have the Comparison dashboard, which is where different systems can be compared. Or the same system can be compared at different locations or with different details, for example, with or without spray applications. First thing we need to do is register an account. This is the home page of the platform. Here, users are directed to summary information about the platform, news and events, and other useful links. To register an account or access an existing account, the user must select the option at the top of the page. The platform is currently available in several languages, and additional languages will be added as the platform develops. New decision support systems are translated as part of their integration process. There is a simple registration process to set up your account, but users do need to accept our terms and conditions before using the platform, which is largely to protect users and developers from the misuse of the systems hosted here. Once these are accepted, the user gets instant access to the platform, and the account needs to be verified within 48 hours. An email will be sent to the address provided. Once a farm has been set up, users will always log straight into the DSS use dashboard, giving an immediate summary of current pest risks. In this case, we've set up a digital demonstration farm near Cambridge in the UK, and I've added a DSS for Bali yellow dwarf virus, a disease of cereals. As we can see, the DSS box for this disease in winter wheat is red, indicating that this system is active and the model is forecasting a high risk for this week. If the box was grey, this would indicate that the system was inactive, so the disease is not expected to be a risk to crops at this time, and the model is not running. Alternatively, the risk may be yellow, which is a medium risk, or red as a high risk. As well as the colour risk status, there may also be an alert on the model, the coloured exclamation marks. These indicate that there is additional information about the model that should be considered. If we hover over the DSS box, we can also get some further information on what the model is doing. In this case, estimating the risk of transmission of the virus, which is associated with the emergence of winged or alate aphid vectors in the crop. We can find out more about the model by clicking the eye symbol. This gives a little more detail about the warning status and background information. But let's have a little bit of a closer look at the model outputs. If we now click on the model, it opens up a detailed screen. We can see risk status for our crop over the next few weeks and the model parameters that are predicting these risk levels. If we click on Show Data Legends, we can see chart axis titles as well. The T-sum chart indicates accumulated daily air temperature above a baseline of 3 degrees Celsius since crop emergence or the last insecticide spray. Based on localized weather data, T-sum is now approaching 170 degrees. And when T-sum equals 170, winged aphids that act as vectors for BYDV may emerge. The guidance suggests to monitor vulnerable crops for in-field activity and apply suitable treatments according to need. Then, update parameters when any insecticide applications have been made on the IPM Decisions platform. The model assumes that no aphids are found or an effective insecticide treatment is applied at 170 degrees and then restarts calculations. Now let's consider that the farmer has looked at this, followed the guidance to inspect the crop, and found aphids are easily seen, and based on the model, likely to soon produce A-lay aphids that spread BYDV. They make the decision to make an insecticide application based on this supporting information and add that data into the platform using their Edit Parameters option. Saving this information updates the model. Now we can see that risk has been updated to reflect the application of an insecticide. We can look in more detail at the chart using the expansion box. The estimates across the dates shown are now easier to look at in this format. We can also adjust the dates that the chart covers using the options below. We can also export the data by clicking the green download button. So how did we set up this location? This is through the Farm Management tab on the left-hand side, and this is where you'll be taken when you initially register on the platform. Now I will show you how to set up a farm location on the IPM Decisions platform. To create a farm, you name it and select the location from the map. There will be a delay between setting the farm up and the weather being linked to that site. This is simply because there is a large amount of weather data behind each location, and these are only drawn into the platform once a new location request is made. Once the farm is named and the location selected, it can be saved and the DSS can be added. To do this, you go back to the Farm Management tab. Here, you can edit, copy, or delete a farm. We'll select the Edit icon. At this point, we can either edit the location or add DSS. Let's add a DSS model. DSS are added by relevant crop, so you select the crops that you're interested in and then the associated DSS. You can add multiple crops by holding down your Control button and selecting all crops by selecting Control and A. For now, I want to add a DSS for a potato crop. An example DSS available for potato is for cutworm. Now, this is mainly a problem very early in the season rather than in October when this system is being demonstrated, but it will serve for illustrative purposes for now. I can see that this model is appropriate for potatoes and is relevant for use in several regions in Europe. I can find a bit more detail through the eye icon. This presents a description of the model, including what it's for, briefly how it works, who developed it and where, and any assumptions that should be considered. Once we are happy to use the model, we can select it and it's added to the Use dashboard. Now you can see that the cutworm model has been added alongside the BYDV DSS that we looked at earlier, and it's reporting a high risk alert. Let's click on that and take a closer look. This model is calculating the number of batches of first to third install larvae that could be present in the crop. A batch is a generation of larvae from the last egg laying, and once the batch reaches fourth instar, it moves into the crop tissue and surrounding soil and cannot be treated. When 4 or more batches are predicted to reach fourth instar, a high risk is indicated. Here we can see that the system is forecasting more than 4 batches of first to third instar larvae, which could be active in the crop, and the guidance is suggesting in-crop monitoring to assess the actual risk. This high-risk status has been shown since the end of June. Let's say the farmer on this occasion is intending on applying a treatment tomorrow. We can add that into the system by editing the parameters. I will add a spray application for tomorrow, and let's see what that does to the system. Back to the dashboard, and the risk is still high, because of course spraying tomorrow hasn't reduced today's risk. But if we look in more detail, now the model assumes that the spray application has effectively removed all larvae and has reset the model to 0. We can continue to track the model and ensure that sprays are timed to be most effective and minimise the number of applications. A further function of the platform is to enable comparison of models, treatments, or locations. Let's say we're an advisor supporting 2 neighbouring farms and we want to compare risk. We add our second farm. We add the DSS we want to use on that farm, in this case for cutworm on onions. So here I will report that a spray was applied in mid-August. Save and update. And now the risk is medium. So the number of batches reaching fourth instar isn't yet at the threshold of 4, but it could reach that soon. You can add as many locations and DSSs as you would like, but it gets a little difficult to compare what's going on. So we've developed a comparison dashboard. Once your farm location is selected, click Save and you'll go back to farm management. In the comparison dashboard, we can select up to 5 different models or locations to compare. I will pick the cutworm model at each location. See them contrasted against each other now, with the low to medium increasing risk at farm 2 and the high changing to low risk at my digital demo farm. As the number of DSS on the platform grows, this tool will enable users across Europe to compare systems developed in different regions and make decisions about which are most applicable to them. The third dashboard enables users to edit core parameters within these models, adapting them to local pest phenologies in order to better support local decision making. As well as accessing several integrated DSS in the IPM Decisions Platform, you can also see and access linked DSS. You can access the linked DSS by the linked DSS dashboard on the left-hand side. From here, you can see a range of linked DSS in the General Overview section. You can filter by crop to find DSS by selecting one or more crops from the list provided and selecting the filter button. DSS now shown in the general overview are applicable only to those crops that you selected in the filter. You can now select one or more of these so that they are more easily found another time. Make sure to confirm your selection. Now, the DSS linked dashboard has the DSS we're interested in highlighted in an easily accessible section of the page. But we can also still see and explore other DSS within the General Overview section. Similar to the other dashboards, selecting the eye icon will provide you with more information on the DSS. For example, here we can see more information about the Best for Soil Nematode Support tool. If you would like to then use a linked DSS, click the DSS title text and another page will open for the website hosting the DSS. Users can compare DSS in the IPM Decisions Platform. If multiple DSS are active in providing results in the use dashboard, you can also compare the results of these DSS in the DSS comparison dashboard. First, select the DSS comparison dashboard option from the menu on the left-hand side of the web page. From here, you can select DSS to compare from the drop-down menu. Click the Compare Models button to continue. If you scroll down, the selected DSS will then be displayed and you can compare the model outputs across each DSS. Clicking on the blue box in the corner of each model allows you to view the data in a pop-out window. For example, here we can see the calculated BYDVT sum values over time and the associated risk status.